Hello again, pre-calculus students. This lesson is a continuation of our previous one on Gaussian elimination techniques. And in this lesson, we're going to show how to graph a circle or a parabola through any three non-collinear points. I'm going to use this equation for a parabola. And the reason I'm going to use this equation is because it has three unknowns, A, B, and C. And because I'm going to use 3 points, that'll give me 3 equations and 3 unknowns, and I can solve that system. Similarly, I'm going to use this format for a circle. And this format is called the general form of a conic. And I'll show you at the end how we can actually group these terms, complete the square, and put this in standard form. But for right now, I'm going to use general form because, again, it has 3 unknowns, D, E, and F. So that this doesn't get too confusing, let's go through it just a little bit at a time. Here are the 3 points I'm going to use. What I'm going to do is substitute each of these 3 points into this equation, and I'm going to end up with an equation in A, B, and C. So if I substitute 2, 0 in, well, x is 2, so I get 4a. X is 2 again, so I get 2b plus c equals, and y is 0. If I substitute 3, -1 in, again, x is is 3, so I get 9a. I get 3b, I get c, and that has to equal -1. And we can substitute 4, 0 into this equation and get this one. So I now have a system of equations, 3 equations and 3 unknowns. Now remember our rules for Gaussian elimination. It's greatest if I can have a 1 or a -1 up here. It makes life easy when we try to clear out what's below it. I don't have that here. So I'm still going to use this, it's called a pivot position. Wish we had time to study matrices. It's just so cool. That and logarithms are my 2 favorite pre-cal topics. Anyway, we're going to multiply this first equation by a non-zero constant, because that's one of our rules, 9. And I'm going to multiply this equation by 4. So I end up with 36a in both cases. Don't forget to multiply these terms by 9 and 4. And then I'm going to replace row 2 with negative row 1 plus row 2. So I'm going to take the negative of the first row plus the second row. Remember, you cannot ever have a minus row 2 here or plus a 3 row 2. It always must be plus row 2 if you're replacing row 2. And when we take negative row 1 plus row 2, we've eliminated that position. Now we need to eliminate this position using this 36a. So I'm going to multiply row 1 by 4 to get 144, and row 3 by 9 to get 144. That's just the least common multiple of 36 and 16. And now I have used that first position to eliminate everything below it. Now I need to use this position to eliminate what's below it. Don't worry about what's over here if you can easily get rid of that. Don't worry about what's up here. That is not the algorithm. Once you've used this position to clear out what's below it, go down and to the right. Now use this position to clear out what's below it. And I see that Wow, that's a -6, which goes into -36. So if I could make that a +36, they can cancel. So I do -6 row 2 plus row 3. And that plus row 3 and this arrow down here tells me I'm replacing this equation in row 3 with this. So -6 times this is -6, is 36b, minus 36b is 0b. -6 times -5c is positive 30c, plus -27 is positive 3c. -6 times -4 is positive 24, plus 0 is 24. Now I am in echelon form. C equals 8. Substitute, or we call it back substitution. I'm going to put that 8 up into here and solve for b. B is equal to -6. Now I'm going to take C equals 8, B equals -6, substitute them in here and solve for A. So my solution is 1, -6, 8, or A equals 1, B equals -6, C equals 8. And remember that A, B, and C came from this equation. So I'm going to substitute that 1, -6, and 8 in here. And that is the equation of the parabola that, that we can draw through those 3 points. Well, let's confirm that by using some graphing software. Rather than using Desmos this time, I'm going to use some graphing software I have on my computer. It's called Graph, and it can be downloaded from obviously a Danish Star Wars fan, Padawan.dk, Padowan.dk. So anyway, here I've graphed these 3 points. You can see that they are the points 2, 0, 3, -1, and 4, 0. And here's y equals x squared. You can't see any of that. I do that all the time. Okay. My bad. Alrighty, so anyway, here are my 3 graphed points, as you can see here. And here is y equals x squared minus 6x plus 8. When I activate that graph, you see it goes right through those 3 points. So that's the evidence I need to show that I did my work correctly, and that this graph is the graph that will go through these 3 points. It is the only parabola of the form ax squared plus bx plus c that can go through those 3 points. Alrighty, so next, let's pick 3 points and draw a circle through them. So here are my 3 points. And as I said, I'm using this form of a circle. This is called general form. All conic sections can be written in this form, only there'd be an A and a C. Sometimes there's even a BXY, but that causes the curves to rotate. And none of us wants to deal with, rotating conic sections. Not at this level anyway. So here are the 3 points. So I'm going to substitute those 3 points into this equation, and I'm going to end up with 3 equations. Because I'm substituting into x and y, my 3 equations are going to have unknowns of d, E, and F. So when I substitute 5, 3 in, I get this equation. When I substitute negative 2, 2 in, I get this equation. And when I substitute negative 1, negative 5 in, I get this equation. I need to take all these constants, move them to the other side so that I have a nice system of equations. So it's 5D plus 3E plus F. This is 34, so that would be equals negative 34. Then I take this positive 8, move it over here. I take this 26 and move it over here. Now, I could use this 5 to clear out what's below it, but I'd rather have this negative 1. So I'm just going to interchange these two rows. That's one of my 3 allowed rules in Gaussian elimination. I can interchange 2 rows. Now, the first thing I'm going to do is I'm going to do 3 operations at once. That's allowed as long as I'm following the rules. And I have a negative D minus 5E plus F equals negative 26. I'm just going to make that all, positive D, make life a little easier for myself. And then I don't use this equation up here as row 1. I'm still working back here, so this arrow comes from here. So I take negative 2 times row 1 plus row 2. That gives me a positive 2D, a negative 2D, and that cancels. So I've now used this pivot position up here to eliminate the 2 places below it. Now I go 1 down and to the right, and I use this one. Don't try to come over here and cancel the F's first. That is not the algorithm. That is, ooh, I see I can do it, let's do it. That's not the step-by-step algorithm. You can't program that. The algorithm we're using, you could actually program. So first thing I'm going to do is multiply this by 6, because I recognize that the least common multiple of 12 and 22 is 132. Because this is 12 times 2, and this, I'm sorry, this is 11 times 2, and this is 11 times 12. So I can recognize that. Now, I just do 11 times this row plus this row, and I've used this pivot position to eliminate what's beneath it. I can now solve for F, and then by back substitution, I can solve for E, and by back substitution with F and E, I can solve for D. So the general form of the equation of the circle that goes through those 3 points, recall that our circle was x squared plus y squared plus dx plus ey plus f equals 0. We just solved for d, e, and f. So here's the general form of the equation of the circle. Now, where's its center? What's its radius? Now we do our factoring. So I group the x squared and the 4x together. I group the y squared and the 2y together, and I bring the 20 to the other side. To complete the square, since that's a 1x squared, I take half of negative 4 and square it. So if I add 4 to this side, got to add 4 to this side. Same here, I take half of the 2, which is 1, and square it. I added 1 here, I added 1 to the 4. That's where that 5 came from. Now this is called completing the square. So these are perfect squares. I'm going to tell you now, Too many pre-calculus students do not know enough about how to factor. That is a flaw in our integrated math series. It is crucial, if you want to succeed in this course, that you know how to factor, that you do it well. So this is x minus 2 quantity squared. Remember, we took half of the -4 and got -2. Now, if you FOIL this out, if you say, ooh, that's x squared plus 4 or x squared minus 4, I'm going to tell you to go back and write x minus 2 times x minus 2 and FOIL it out and learn how to factor and FOIL. This is half of that 2 was 1, so it's y plus 1 quantity squared equals 25. So through those 3 points, this is the only circle that can be drawn. Let's pop back over to graph. This time I'm making sure to share my graphing screen with you. So here I got those 3 points graphed, 5, 3, -2, 2, and -1, -5. And then here is x squared plus y squared minus 4x plus 2y minus 20 equals 0. When I activate that, we get the circle going right through those 3 points. If you want to see that that standard form is the same circle, let's insert a relation here, and let's say x minus 2 quantity squared plus y plus 1 quantity squared equals 25. And we need to do this in a different color. That'd be a cool color. We'll do it with this, we'll do it in bright yellow. So as soon as I activate that, it should be the same as this circle. And it is. Yeah. Why is it doing that? I should just be able to turn it off, turn it on, turn it off, turn it on. Same here. Oh, the yellow one is covering the teal one. All right. So anyway, now you see how we can use the Gaussian elimination process to find graphs through points. And to be quite honest, that's kind of the technique that the same software packages do when you ask it to find like right here. If you have some, that's point series, trend line. That's a function. Ah, right here, I'm sorry. When you have it, select a curve of best fit through a bunch of points, it will use algorithms based on what we've just done. So that's all I have for you now. Have a great day.